Okay, how is everyone feeling? How are you liking your talks today? So for our next talk is Josh. He works at the Daily Drip, and it's a really cool app that will give you like 5 small drops of knowledge during the day. It's pretty cool. You should check it out. He loves Elixir, but he also loves Elm, and he's been coding for like 16 years. And when he's not coding, he likes to code. So,
yeah. So hey everybody. Today we're going to talk about building an open source real-time forum with Phoenix and Elm. And actually, give me 1 second, because of course, this whole time I could have been unmirroring these displays, and I didn't know about it. Oh, I'm sorry. Someone tell me how to do this. This is fantastic. There we go, mirror displays. I find it eventually. All right, we're good to go. So back to this. So I did a thing called ElixirConf. It's now transitioned to being Daily Drip, but we produce daily continuing education content for Elixir and Elm and a bunch of other things. And today we're going to talk about building an open source real-time forum using Phoenix and Elm together. So if you haven't heard of the project before, it's called Firestorm. Those are emoji. This is a logo. And it's a Phoenix-based forum with an optional Elm client. And it was kickstarted. So one of the goals, so the reason that we wanted to build this is to have a forum, have a production app that people could look at and tinker with that was an open source project that actually was also a usable tool. And so, for instance, we're sharing things like our SEMAPHORE continuous integration and deployment setup. We're integrating with services like AppSignal, all in an open source project. It's here for you to use in your apps, and you'll see it in a moment. So please do that, embed it, work with me. I'll help you integrate it if it's hard. Like I said, it was funded by Kickstarter at the end of last year, and we spent 10 weeks planning, designing, and building a prototype and having these weekly design meetings with all the people that were patrons. And then I was really waiting on Phoenix 1.3 to come out so that I could start from that and not from a previous version. And so we started building it from scratch in episodes. So we have episodes on Daily Drip, working through building the Phoenix side as well as part of the Elm side. So here's where you can see the code, and you can see the website, and you can actually use it. And we're very close to hitting 1.0, and after we do that, we're going to have a Slack client. So enough about that. During the talk, we're going to spend the first 15 minutes or so discussing the Phoenix backend, the Phoenix bits, and most of that is going to be talking about the awesome libraries that exist in the ecosystem because they make things so easy. Then we'll cover the basics of Elm, and we're going to walk through the code for a real-time client. And the goal of this is to be an alternative to Discourse for comments or a forum system or maybe even a blog, right? They're the same thing for the most part. And also to be a good mailing list interface, because I wish that mailing lists still were a thing, but they've always been terrible to use. And Google Groups is really bad. It's not as good as Google Groups yet, though. Anyway, so as part of the Kickstarter, the patrons also funded 5 weeks of free screencasts. So if you have anybody that you're trying to convince to learn Elixir, we've got 5 weeks of content that's Intro to Elixir and Ecto and OTP and Phoenix. So all free, and I like it. Anyway, here's a link where you can see all the patrons, and you can also see the content. And these are the patrons, and there's a reason that I'm focusing on the patrons so much. So this is the website, and these are the patrons that are grouped on the site by level of patronage. And they made it possible to spend time building Firestorm and paying a designer for it. And any faults that still reside in the software are ours, but they made this thing possible. Is anybody here that contributed to the Kickstarter? There's a couple of people, anyway, but that's the people in the audience. Part of the point is to remind you that there are a lot of people out there that want to help you succeed, these fine people, but also this giant list. So there's a whole lot of them. The list keeps going on and on and on. And the reason I'm bothering doing this is first and foremost because they deserve respect, right? I wanted to show respect to the people that made the open source project possible. But also I really want you to know that people are rooting for you. You're not working in a bubble, and there are real people out there that want to help you make a project succeed. I hope that more open source software can be funded with things like a Kickstarter, especially if it also leads to educational content around the language it was built in, because I'm a big fan of educational content. We haven't quite completed it yet, but we're getting really close. If you're interested in starting an open source project for Elixir, or for anything really that's somewhat ambitious, and you do end up crowdfunding it, let me know. I'm probably going to back it. There are probably plenty of people in this room that would be interested in backing it if it's an interesting project. And I want more open source code. So if there's a way to get more of it, I'm interested in proselytizing for that. Anyway, if you want to talk about all this junk, track me down and talk about it. It's not the point of the talk, but I do like to talk about open source stuff. So let's have a quick demo of Firestorm. It's not terribly lengthy. It's a functioning forum. We have OAuth support. You can also just make a user. It works like you would expect a forum to work. We support OEMBED. We have post previews. This is really cool. We're using Earmark here, and we're able to customize it to add features that it doesn't have or that Markdown doesn't necessarily support out of the box. So this is really fun. And we also support like Amazon S3 direct upload. So if you're ever working on a project and you're like, hey, how do I handle client uploads? That's in this open source project. Anyway, one of the things that's been so great about building Firestorm is how easy it's been to do a lot of stuff because of packages. So I wanted to spend some time just talking about the great Elixir ecosystem that we have. One of the things that Elixir got right really, really early on was Hex. Thanks, Eric. It's a great package manager and related tools. If you've not worked in a language that doesn't have a great package manager, you might not know how awesome it is. But I came from Erlang, which had none, basically, and Ruby, which had a pretty good one. And you can see the difference. Like in Erlang, now you can put packages up on Hex, but previously there was not a huge community. There wasn't a place to go to see all the packages available for the language. Hex gives us that, and it's awesome. One of the packages we use, Phoenix, you might have heard of it. Anyway, so it's a productive way to build web apps. If you haven't done it, you should do it, but you should use it. But it also supports channels, so that's really great for real-time stuff, which it turns out I care about. So in our case, every entity in our system, so all of the things that are in the database, they have a channel that they broadcast updates to. So when they're changed, they tell anyone that's listening for that particular entity. And so that enables this sort of thing. On the right, we have the OM client, and on the left, we just have the Phoenix HTML site. And we can make a new thread, and over here, we already know about the category. So we've opened a channel, so we're listening to updates about this category. And so now we know there's a new thread because someone made one. And then, obviously, a reply to a post works the same way. So we're listening to channels for everything in the system. We're just listening for updates, too. And if you notice, when you actually reply, it shows up on the LMAP before it's even gone on the HTML side. And it's really easy to do. So this is an example. When we create a post, we create this response type that all these things have, and we tell the front end about all the stuff we'd like it to update. So I want you to know new stuff about the thread because maybe there's a new count on it. Here's the user that made this post, and here's the post itself. And so now my client side knows all this stuff, any updates that happened, and all we do is broadcast. So I broadcast to this particular thread's channel. If you haven't done this sort of thing before, it's really, really fun to have each resource have its own place it updates things. Anyway, so this is one of the reasons Phoenix is awesome, because there's essentially one line of code to do real-time stuff. Earmark is what we use for the Markdown. It's a fantastic Markdown parsing library from Dave Thomas. One of the things that I really like about it is that it's easy for you to inject your own logic for the most part. So an example of this is if you look right below the heading that says project, we have a couple of emoji. We just made a little parser that would take Slack-style emoji strings and turn them into emoji. Super easy to do. So here's an example of our whole Markdown parsing pipeline, which is tiny, right? We sanitize the HTML, and then we pass it through Earmark with some custom options. The most important custom option being the renderer. So in Earmark, you can pass in your own HTML renderer and change how you output HTML. So we did that. We copied and pasted the existing one and just changed inside paragraphs. We added these 2 lines at the end of the pipeline where we auto-link any bare URLs, and we replace any emoji before we return the paragraph tag to you. So the point is it's super easy to extend Earmark, and that's really cool. If you wanted to see what one of here is an example, those 2 things that we do, they should be really plugins. So this is an extension point where we could maybe configure you with a list of modules that you'll run these functions. You pipe this data through those functions, and that could be how you do a plugin for text. Anyway, so we're going to play with that. But this is very basic Elixir code. It fits on a slide. But again, we're going to play with the package ecosystem. So this is an emoji replacer. It has a regular expression. And every time it runs into that pattern, it's going to try to replace it with this emojify short name function. And so all I'm doing there is using this Xmoji package. So again, just going out to the community. And it's essentially an emoji database. You can look up emoji by name. Cool. And you can also render them. So super easy, but in one slide, we can do Slack-style emoji replacement. I like it. This is not in the Elixir ecosystem at all. But if you want to do code highlighting, Prism.js is awesome. Way better than all the other ones. We also added support for OEMBED on the server side. So if you don't know what OEMBED is, you'll see it in a moment. But essentially, it's a way for when you paste a YouTube link in Slack and you see the YouTube video. That's essentially provided by OEMBED. And we could have done it on the client side. It's very common to do it on the client side, but we have two clients, right? We have the HTML client and or more bare JavaScript client, the Elm client. We didn't really want to implement the same thing two places, so we do it on the server side. Here's an example of it working. So we just pasted some links, and it pulled in these sort of OAuth cards. Again, this is a tiny package called OEMBED, or Elixir OEMBED on GitHub, and it makes it super easy to get OEMBED data from a URL. Here's what it looks like. So you can go out and say, hey, give me the OEMBED for this URL, and if it succeeds, you'll get this OK result tuple. And this is the kind of result you get. So among other things, it gives you a thumbnail URL, so you can see what the video is supposed to look like. Anyway, so this is how the OEMBED package works, and you're not supposed to read that text. But this is slow, because it's doing this in the middle of the request, right? We're piping through and pulling these things out. So if you actually do this in the request, it's going to suck. You're going to make a request for the same data over and over and over again. So we know what to do for this. We introduced a cache. And this is an example. In my case, I use this LRU cache package. It's really cool. It's the least recently used cache. I would probably use CacheX going forward just because it has a lot more features. I wanted to make sure to call it out if I'm mentioning a package about caching. But this is an example of why Elixir is awesome, because if I were in a Ruby project and I had this situation, I would say, I need a cache. Now I need an ops person because I need to bring in memcache or something, right? And I don't really need that. I've got it in the runtime. So turns out the Erlang runtime, really good feature. Anyway, using LRU cache is super easy. I just start a worker. I say it'll hold 5,000 results. And then I write a module that wraps the existing OEMBED thing with the same API and just checks the cache. So if a URL isn't in the cache, we say, hey, there's no OEMBED data for that. But then we immediately kick off a task in the background that's going to fill the cache. So again, this is a thing, in another language, I might be calling out for a background job or something. Here I'm just starting a task, and it's going to happen in the background, and everything else goes on its merry way. Anyway, so just yet again, Elixir makes things that were once complicated super easy. We also support OAuth. If you want to do that easily, check out UberAuth. If you haven't played with it, it's awesome. If you have, you know that. We use BODYGUARD for managing policies around who can do what. It's similar to Pundit if you come from Ruby. And it's really easy. You just define a policy that either says OK or doesn't say OK. And that says whether or not someone can do something. So here you can only edit a user if you share IDs with the user. Anyway, that's just an example of a policy. But again, the point of this was in large part to also show off a production app. Make it easy for people that maybe only play with Elixir on the side to have full insight into what a production app might look like. So among other things, we share our SEMAPHORE setup for continuous integration and continuous delivery. So I like SEMAPHORE. There's lots of other hosted continuous integration services you could use, but they're really cool, and they've been very friendly to Elixir for a while. This is what it looks like when you run a test on SEMAPHORE or on a given test service. So every time I make a commit, it runs tests, and I can't merge a pull request unless the test passes. In this case, this was a merge because it was a commit to master. And you can see right there kind of in the middle of the screen where it says it did a deploy. So that's saying, well, since this was a commit to master, it went ahead and did a continuous deployment, and that's pretty swell. And also on GitHub, if you haven't done this sort of thing before, it will sync with GitHub. So on GitHub, you can see this commit right here passed the test. So there's a history of tests running on every commit. It's a very nice thing to have if you've not done continuous integration. We are actually deploying to Heroku. I'll be doing proper releases and deploys later, but it turns out it's just too easy to get started on Heroku. So that's what I did. And also there's app monitoring. So if you're running in production, you'll have app monitoring, where if you're not, if it's sort of a toy project, you might not. We're using AppSignal, and it's really nice. Just if you haven't seen it, this is what my events over time is over a month, maybe not. Anyway, lots and lots of data you can dig into there. For instance, how fast something's running, how long a particular database query is taking. And then there's another option for application monitoring, and the founder of Pryan sent a pull request that integrated Firestorm with it. So I told myself I had to show this. Anyway, so this is, he's one of us. He's in the Slack channel and everything. And yeah, it's just, in this case, it's gathering data about my processes that are running on a particular node. It's showing how the scheduler is doing across the CPU. And it's like, 15 minutes of effort to put this into your system. And then, I should have said this earlier, but WALLABY is what we're using for tests. So does anybody do browser-based testing at all? Anybody? Has anybody used WALLABY? Does anyone not like WALLABY? Okay, yeah, so WALLABY is really good. It can drive, if you don't know what it is, it drives a headless browser to perform actions in your app. And also the test can be run asynchronously, which is hard to do if you're like in Ruby land, but that's because the actual browser driver is aware of the different transactions going on with your asynchronous tests. And that's like some interesting magic in Ecto that supports this, or that enables this, but talking about it probably doesn't add anything to this talk. This is what a test in WALLABY would look like. So in this case, I'm just creating some data. I'm logging in as the newly created user. I'm visiting a particular category. I'm clicking, hey, I want to make a new thread. Click the new thread link. I fill in a couple of fields. I click the create thread button. And then it asserts that, hey, you were redirected and you have the right title. So this is an example of, very trivially being able to, that's like 4 different routes that I ended up visiting. If you haven't done this sort of thing, you should, probably. You probably shouldn't overdo it. It's very good to do integration tests for like the important happy path of your system, but I've seen a lot of people try to do unit tests with integration tests and don't do that. Anyway, but this is really cool. If you haven't seen WALLABY, I wanted to make sure you saw it. And one of the really cool things about WALLABY is it also supports headless Chrome. So headless Chrome is a relatively new thing. But I just saw this benchmark today, and it was just visiting like the Rails starter site a whole bunch of times in a row with both headless Chrome and Phantom.js, and headless Chrome was twice as fast. So you probably don't actually get to double your integration test speed by switching to headless Chrome, but it probably matters. It's real fast. Anyway, so that's kind of the just a bunch of packages I just wanted to call out because they were awesome. We also built the app with a basic HTML front end, even though my focus is on the Elm client. And this is because we wanted it to be a useful tool for people to learn Elixir, learn Phoenix, get comfortable with building your own app. Anyway, so on the HTML front end, we switched out to use Webpack. Another reason to love Phoenix is it's not painful to switch your asset bundler. There are other frameworks where that is not the case. Yeah. And the only reason I use Webpack is because I spent a whole lot of my time learning all this stupid stuff about it, and I don't want to learn more stuff. I want to use that stuff. We tried really hard to make Firestorm easy to skin. We haven't really tried it yet because no one's doing heavy integration. But if you want to skin it and you have any trouble, talk to us. We'll make sure it's easy. But I wanted to talk about the CSS a little bit because it's the first time I've been happy, like actually enjoyed working on CSS on a project. So we use a modified form of what's known as the inverted triangle CSS architecture, which I'll show a maybe helpful picture of momentarily. But also outlined it. So there's a blog post that goes into it in depth, as well as an episode where I outlined sort of building up my front-end stack in Phoenix, which discusses this in pretty good depth. But this is what it looks like. Essentially, with inverted triangle, the most generic stuff goes up top, and the most specific stuff goes in the bottom, and you have kind of this gradient. And the reason that's important is because it helps you avoid like having your CSS step on other CSS. But it also just, there is a system where stuff goes. Like, if you've ever wondered, hey, where do I put this? I know, at the end of the CSS file, because that's what people do. That's not really legitimate here. But you have to have a system or else you'll fall into that. Here's an example of our file, and I'll actually kind of switch between these two. This is our main level SCSS file, and again, it goes from most generic to most specific from top to bottom. So it matches sort of this pretty much exactly. And so we go through like having these generics and then typography and layouts and pages, and finally we get to components. And so components are like the building blocks of the actual UI. And we manage those with this other methodology called RSCSS. And again, the only reason I'm going into depth on CSS stuff is because this is easily the happiest time of my life in terms of styling. And it seemed worth mentioning to people because I've been pretty unhappy doing CSS before. So as far as RSCSS goes, you have these ideas of components, and there are things like this search form. You have these concepts of elements. So within the component, there's a field and there's an action. You can nest components. So there's an article link component, which holds a vote box component. And you have this concept of variants. So if you've done anything like BEM for CSS, and there are a lot of people that probably haven't done any CSS and don't care about this at all. But if you have done something like BEM, this is like a much less typey version of BEM. And ultimately, here's what a component looks like. So this is our action bar in Firestorm. It just has some stuff on the left and some stuff on the right, and we put it at the bottom of a form for the most part. And that's the whole like component file for it. again, just kind of trying to talk through these things. So that's like, I've covered very rapidly the basics of what Firestorm sans Elm looks like. And I mostly wanted to spend time doing that because I wanted to call out all the people that we get to build on top of to make stuff. Because if I'd had to write every one of those things that I'd spent 15 minutes going through, I never would have made it for them. I would still be trying to make a markdown parser. So I just wanted to get that out of the way. Next, we're going to move on to discussing the Elm front end. And so the way we're going to do this is we're going to talk about Elm, the language. We're going to look at a very basic intro. We're going to try. Has anybody played with Elm before here? Okay, how many people have not played with Elm, just so I can compare the? There's about 50-50, I think. How many people have played with Elm and decided it wasn't for them? Awesome. Yes, there are some. It's not for everybody. It is for me, though, because if you've talked to me or seen me give a talk in the last 18 months, it's probably involved Elm. It's kind of my favorite thing, aside from Elixir now. So anyway, we built an Elm front end. Elm is a language. That's its logo. And it's a delightful language for building reliable web apps. I've used it for a year and a half, and anytime I talk to somebody about programming, I probably bring it up. People like it because of these reasons. It's functional, it has a friendly compiler, there are no runtime errors, and the Elm architecture. And if you haven't ever heard the phrase the Elm architecture before, how many people have heard of Redux? Okay, so Redux was based in part off of the Elm architecture, and the whole idea of like data going down and actions going up sort of is the core concept. We'll get to it in a little bit. As far as it being functional, it is a pure functional language. It's a derivative of ML. It looks Haskell-y. Function calls are implicit, so instead of calling add and putting parentheses around and 1, 2, add space 1 space 2. Okay, so you've now learned most of the syntax. Up at the top, we're defining a function that takes 2 integers and returns an integer, and we call those things x and y, and then we just use the infix plus to actually implement the function. So this is like, your first taste of Elm if you haven't seen it. The last bit is kind of interesting. So add is a function that takes 2 arguments, but if you look, when we make add 2, we only give it 1 argument, right? And that partially applies it. So now it returns a function that's waiting on 1 more argument. So actually, any function in Elm only takes 1 argument, actually. So that add function takes 1 argument and returns a function that takes an argument. So anyway, my point being, hey, look, it might look kind of weird, but it's not really. It's strongly typed. It has a Hindley-Milner type system, so again, Haskell-y. But it's coupled with an unbelievably friendly compiler, the nicest compiler I've ever used. Here's an example. This is called a union type. So we have the type fruit. If you're a fruit, you can be a banana, an orange, or an apple. That's the only things that are fruits. So we have a function here that can display a fruit. It'll turn a fruit into a string. So we have a case statement, and it handles banana and orange, but it doesn't handle apple. And so we can't compile it, and the compiler tells us, hey, it turns out, buddy, you got to account for apple. And it says, add a branch to cover this pattern. And if this isn't clear enough, here's essentially blog post explaining it in more detail. Like, this is a good error message. This is better than, so I've seen error messages, you might have before, that say, undefined is not an object. I've seen error messages that complain that nil doesn't have this method. In fact, there's an undefined method error on nil, which most people don't know you can fix by defining the method on nil if you're in like Ruby. It solves a lot of problems. Anyway, there are also no runtime errors because you're always required to handle everything. So if you find a runtime error in an Elm application, you're supposed to file it against the compiler as a bug. So like, that's pretty cool. That's nice. He takes all of your runtime errors upon himself. And then we've got the Elm lifecycle, and this is just sort of I try to explain how Elm works with this diagram. I've tried to find better diagrams. I always struggle. So the green things are functions that you have to define and give when you're making an application. So you have to explain how to deal with subscriptions. These are things that happen in the outside world. You have to define a view function that'll turn your model into some HTML. You have to define an update function that can take a thing that happened, a message, and your model, and produce a new model, and maybe produce some side effects, and we'll talk about that in a bit. But then there's that bit in the middle that's the runtime. And so I think that's very interesting. So it's the thing, if you say like, in Elm, if you want to make an HTTP request, you don't make an HTTP request. You say, it'd be awesome if somebody would make this HTTP request for me, and then you wait. And then the runtime does that and calls back into you. And that's the way that you're able to be like pure, but still have things happen. Anyway, so one of the great things about Elixir is the runtime system. That's why we could do things like spin up the cache so easily and do background tasks. Elm shares this idea broadly. So the Elm has what's called platforms, but it's the runtime essentially. For now, there's just the browser platform. That's all they're worried about. There will be a server-side platform eventually, I believe. Every indication is that there will be. But also, someone's working this summer on an iOS platform for Elm in the Google Summer of Code. And so you can build, think React Native, but for Elm. So if you like Elm, you can build phone apps in it. I mean, you already could, sort of, but this is going to be better than hooking into React Native's tooling, which is what we were doing before. So that's the basic gist of Elm, but we're actually going to walk through a bit more. So in terms of syntax, you've seen a little bit. Here it is again. You can see concatenating a string there in the middle. You can see defining functions there in the bottom two. You can't really define functions. You have to do that inside of a module, just like you would expect. So modules in Elm are very similar to the way modules are in Erlang in as much as there's one per file. So at the very top, you describe the module. This is the module named foo. It also has to be located at foo.elm, by the way. If you have a different file name or a different path, it's going to complain, which is nice because you always know where a module lives on the file system. And it's only add to function. So we've defined two functions inside of it, but you can't call foo.add, right? It's private. It's not that surprising. Just wanted to show it to you. So you do have to be explicit with everything you make public. Elm being a browser-based language, it's really good at making HTML and making it quickly. Here's a super basic example. This is a view. It takes no arguments and produces some HTML. So it uses an h2, which is one of the HTML functions. And each one of these functions is named after an element and takes two arguments. So the first argument is a list of attributes that the function has. This one has none. The second is the list of children. And so here we put a text node inside of it, and it yields this h2 with hooray inside of it. But it doesn't yield that as a string. It yields that as sort of a virtual DOM representation. And then in the runtime, it does virtual DOM diffing, and it's very fast, like really, really, really fast. There are benchmarks. They're really nice, but like for the most part, just know that it's fast enough. Go a little further. You can add some attributes. So here's us filling in that first argument with some styles. And again, it just produces this sort of virtual DOM representation of the HTML. And so then you make a program, and the program is where you actually tie into the runtime system. So here we've made a program, and we've given it a model. Our model is an integer. It's the integer 0. That's where it starts. We've given it an update function, and we've given it a view. And the view knows how to take the model and produce HTML. As far as the HTML goes, it can emit these messages. So messages are the things that happen in your application. And so from the HTML, we're going to have a couple of buttons that will emit these two messages, increment and decrement. And our update has to handle every possible thing that can happen, right? Because otherwise it won't compile. And so we handle increment by adding one to the model. We handle decrement by removing one from the model. And this is our whole update function. So this is the thing that when something happens out there in the world, this handles the transition of state from step A to step B. And then we have a view that takes our model and produces some HTML that emits messages. That's what that sort of parameter is there. Capital message means the thing that we just said was either increase or decrease. And this is a div. It should read fairly straightforwardly. It looks kind of like some HTML that's confused. And when you click a button, it'll emit a decrement or an increment message, and that'll be passing through your update function. So this is like a quick tour of the basic counter type thing you can build in Elm. I'm not going to show it to you. I think you can imagine the buttons. But one of the greatest things about Elm and that I miss when I'm not doing Elm is it's a really pure functional language. So pure that you can't at all perform side effects. Again, I mentioned you can provide these commands to the runtime, which is your way of asking it to do something for you in the outside world. And it'll do that for you, but you can't do it. Like it's off limits to you. You just return data. So here's an example of a side effect. Some people might know what I mean when I say side effect. All I mean is something that's happening that's not pure computation. So for instance, writing to the screen. In this case, making an API request. So when we click the login button in Firestorm, this is code from Firestorm's Elm client. When you click the login button, it emits this login message. So when we handle that, we don't change the model at all, but we emit a command that says, hey, send a login API request, and when it comes back, handle it with this handle login function. And what that function does is if it succeeds, it's going to emit a login success after it decoded the API token out of the JSON response it got back. And so now the runtime calls back into me, says, hey, the login was successful after I did the API call. here's the API token. And then I just update the API token, so now I'm logged in. And I reset my login form so that when you go back to log in, it doesn't have what you typed in it last time still on it. And then I send out another command which says, hey, I'd like to go to this new URL, categories. So this is a side effect as well. All it's doing is changing the browser location bar. But right, that's a side effect. That's something other than math, essentially. So anyway, so this is all segregated side effects. You will only ever see a thing that happens in the outside world after that comma inside of your update function, essentially. So it's really nice. So looking at our Elm client, I just want to show it off, primarily because it's crazy fast and it makes me happy. It's fast because it actually is prefetching data using channels. So anytime that it finds out about a foreign key that it doesn't know about, it'll just say, hey, I'd like to have this, and get sent it. So by the time you actually click the link that links to it, you already have the data. Anyway, so it's very fast. It's not quite as nice looking as the primary client yet, but it'll get there. Anyway, so I wanted to show it off because like that speed and the ability to model the data the way that I do in the application are what like make me really like Elm. Anyway, so the first thing in our application, so now we're on to the actual Firestorm Elm client. The first thing that we're going to look at is our view. And so all this stuff was wrapped in a layout, right? We had the same kind of top bar and sidebar things around everywhere. So we've got a layout, and inside of the layout, we pass it the argument that is sort of the inner view. And so here you can see a case statement on the current route, and just whatever route I'm on, here's how you decide what view to render. It's very straightforward. This is not, like no one can be confused by the code for the most part, except for syntax or, you know. I actually was very upset when I learned that I had to use 4 spaces for indentation in Elm. This like upset me greatly for like a week. But so if you're like revolting, if you're like pulling back from that, understand that part goes away. But I remember it upsetting me. It's nothing compared to the fact that the Erlang source code has spaces and tabs mixed in though. If you didn't know that, I'm sorry, but no. Anyway, so in the bottom 2 you see we're passing the model through this query function. And so that query function takes our model and returns a view model that like our view cares about. So the model has all this data, and I don't want to give the view all the data. Like think about the data that you passed to your Phoenix template. I just want to very specifically give it a portion of data. And so the query turns my model into just the data the view needs so that I can reason about it better because it's pared down for me. And then if you're doing Elixir, you're very familiar with these pipelines. It's super nice. I just pipe the model through the query that sort of filters it down and reshapes it, and then pipe it through the view that emits the HTML. So talking about queries and view models, these are not a thing that you like necessarily see. This is just a thing that I do, and I like it a lot. So here you can see the function that turns our model into the view model for this particular view. So you see all we have is a record that's got a categories field that's a list of category objects, not objects, but values. And then we have current date because we need to know the date so we can show, you know, a difference in words. And so then our query just takes the model and grabs the data it wants and returns this shape. So now as long as I can write a view that handles this shape, and as long as I can write this query that produces this shape from the model, it'll plug together, right? The pipes work. So if you're familiar at all with React and Redux, there's this idea of like map state to props. Anybody familiar with map state to props? It turns your state into the properties for the thing you have. This is the same thing. So like if the model is the state, and if we call the view model the props, like the properties required to render this, then like literally query is a function that maps the state to the props. So anyway, this is the same concept. And then a page has its own view function, and they just, again, look like your view functions you've seen before. This one's only slightly more complicated. It's rendering a list of categories as an ordered list, and I'm mapping the categories that we got through this bottom function, category view. That's really it. And I don't even use the current data in that anymore, so there's no reason to pass that. Anyway, so this is just a taste of like what, building a view. And each one of our little screens on that is just its own view module. It's very basic. It knows how to get the data it needs from the back end and display it. I wanted to show routing just because it's got one thing that's really interesting to me. So this is the routes. It's just, again, another union type. So like these are all the places you can go in our app, and there's nowhere else you can go. And anytime you deal with a route, you have to deal with all of them. So we have the categories route. Our category route has a like category slug parameter. So you can imagine like /category/foo. That foo part is the slug. But not really, because foo is a string. And we actually parse it and turn it into this internal type called a category slug. And the interesting thing there is I can't accidentally try to create a route for you and accidentally pass a thread slug where it's waiting for a category slug, because they're different types. I actually did that in a production application within the past 4 months. I was passing the wrong ID to the wrong position, and didn't notice it till it got deployed. So this would save, that's actually why I did this, because I can never have that problem again. Like, the type system helps me never have that bug again. That's pretty awesome. I like to shave off bugs. This is just some more parts of the routing, and I just want you to see what sort of there is in building a bigger Elm project. This is a router. It just knows how to route stuff to those routes. This is how we turn those routes into strings. And we have our model, and it's pretty basic. So for the whole app, we care about the current route, the current time. We have the store, which is this local database, and we have a couple of forms and stuff we need to talk to the back end. So just wanted to show the types real quick. These will look just like your ecto schemas for the most part, if you compare this to the Firestorm ecto schemas. This is what a post looks like. And this is, there's this concept of JSON decoder. So I can decode JSON and produce a post, and this just describes in a value a way to do that. It's really cool, but it's also real confusing, so I won't spend a lot of time on it. It's confusing till it's awesome and you don't want to be without it. And then we have threads and categories and users, and they're not that interesting. The store is really interesting, though. So the store is a local database of all the data that I know about. And so this is what my WebSockets are talking to. So I know about categories and threads and posts and users, and then I have some indexes that I use for doing things like looking up by slug, and then there's this thing called wants that I won't get into. So this is the whole store. And inserting a category just means putting the category inside the dictionary of categories, keyed by ID, and indexing it. So like making, essentially I'm going to insert into a slug to ID map dictionary so that I can look up by things other than ID. Anyway, super basic, actually, although again, when I say that, if you're not familiar with the syntax, it may not look super basic. Then we can get a category out. We just need the ID in the store, and we might get a category back. Similarly, we can get a category by slug if we have the slug in the store, and we might get a category back. And the first thing we do is we just get the category ID by the slug, which is coming out of those indexes. So this is the most complicated that any of the code gets, and it's like 3 lines long. Anyway, and then the whole interesting thing, the whole reason I even care about Phoenix and Elm together so much is because WebSockets work really, really well with it. Like Phoenix channels work really well with it. And it's really easy to talk to channels. So I've done some stuff with channels in Elm before where I was imperatively like picking channels I was getting involved in, and then like I was setting these event handlers. Well, this is with normal JavaScript. And then like I'd have to remember to throw away an event handler if something went away, and it was awful, and it was very error prone. It was easy for me to do the wrong thing. But in this code, I have declarative channels. So literally anything that's in my store gets mapped to the channel that I'm listening to. So as new data arrives, I start listening for updates on its channel. And if the data goes out of my store because I don't care about it anymore, I'll stop listening to updates on its channel. And this is just some basic code that knows how to do that. The moral of the story being that it's really cool that I don't have to do anything imperative. I just describe the channels that I care about as a function of my model. Now, all the channels return that same replenish response thing that I showed earlier, which is just a dictionary containing any new entities that we want to know about. And here, to load into the store, I just decode it, and then I emit this load into store message. And then the entire list of subscriptions is handled right there. It just takes the list of channels to subscribe to, and I'm done. And then, as I mentioned, this response is just this sort of dictionary. So this was a very rapid walk through the code, but ultimately what it enables is, because I know about any of these threads, or actually because I know about this category in this case, I'm listening for updates, and when we make a new thread, we're going to notify the category that it has an update, it's got a new thread, and it just shows up. So that was a quick romp through building this thing, but I wanted to go through it because I want to pique people's interest in Elm, and I hope I did that. And also I wanted to, if anybody wants to mess with Firestorm, I'd love to collaborate with you. We've got a lot of people involved, but I want more. Anyway, thanks everybody, and I'm with Daily Drip. You can find us here, you can find the forum there. And does anybody have any questions?
I think we're running out of time, but I think we have time for one question at least. And then you can find Josh during the break.
I'm just wondering, did you do a comparison between Firestorm and Discourse?
No, I haven't gotten, so it doesn't have all the features of Discourse yet. So I haven't gotten that far. We're going to build an importer to bring discourse data over. And one of my goals with Firestorm is to convince Aston that Elixir Forum should run on it. But I have to make the features good enough.
But it should deprecate discourse and move to Firestorm?
I think there's, I don't believe in competition in that sense. I believe there should be competition. So I hope it doesn't deprecate discourse, but I hope some people will use it.
Okay.
I would rather use it than discourse, but mostly because I want to hack around with Elixir more.
That's cool.
All right. Thank you.
Thanks.